All right, in this lesson, we're going to be looking at variables on both sides. And what do you might be thinking, both sides of what? Well, both sides of the equation. So you're going to see x's on the left and the right, or a's on left and the right, and what do you do with that? And again, for some of us, this might be a little bit of a review. I forgot to mention this in the last lesson, but want to look at the key vocabulary, and let's use that as we talk about the problems. So what we're going to do to solve equations with variables on both sides is basically gather all the variables onto one side of the equation, and then do your inverse operations to solve. And sometimes it involves simplifying first. Sometimes you can just go straight into moving the variables so they're all on one side. So we'll still end up using our inverse operations to consolidate those variables. So what I want to do is actually, before we do the first example, skip down to the bottom of the page, and you'll see some steps for solving these linear equations. So don't forget, we're basically thinking about opposite of PEMDAS in general, but you can always simplify first. So simplify by combining like terms or the distributive property, right? And then we want to collect the variables, which means put them all together on one side, which is what the focus of today is. Okay, so we're just building on what we've been reviewing and what we've been learning the last few lessons. So if we take a look back up here, looking at example A, what do we do to move all the x's on one side? Well, inverse operations. No matter what, we do the inverse operations to move from one side to the next. It doesn't really matter which side you move it to, but since there's only an x on the right side, I'm going to go ahead and add the 4x to both sides so I can get the numbers on the left and the variables on the right. And remember, it doesn't matter which side you do it on, right? As long as you have variables on one side. So then negative 9 plus 4 is negative 5x. And then do my regular inverse operations to isolate and solve for x. I'm going to divide by negative 5 to solve for positive 1x. And I'm going to get negative 2. Okay? As always, check. It's a great thing to do, especially on a test or quiz. If you have extra time, check it, make sure it's right. So we're going to get 10 minus 4 times negative 2 equals negative 9 times negative 2. So always go back to the original equation. Now do your PEMDAS in the regular sequence. Negative 4 times negative 2 is a positive 8. Negative 9 times negative 2 is positive 18. 10 plus 8 is 18, so works out beautifully. Okay. Taking a look at part B, so this equation is a little more complicated because we have the numbers in front of the parentheses. So remember, what you can do is you can always simplify by distributive property. So I'm going to go ahead and distribute that 3. So I'm going to get 9x minus 12, being careful with the negatives. Distribute the 1/4, and I'm going to get 1/4 of 32, which is 8x, 1/4 of 56, which is 14. Now, alternatively, if you don't like to multiply that fraction, and since it's 1/4, what you could have done is also multiplied both sides by 4 to get rid of that 1/4. But again, that's an alternative. It's up to you. Okay. And here we've got 9x minus 12 equals 8x plus 14. Remember, it doesn't matter what side you put all the variables on. I personally, when I have the choice, like to keep everything positive. So I'm going to subtract the 8x because I know 9x minus 8x is a positive 1x. And that just saves me from dividing by negative at the end. So I'm going to go ahead and get 1x, or just x, minus 12. Remember, this turns into a 0 pair, so it's gone. And that's a positive 14 left over. So keep doing your inverse operations. And I'm going to get x equals 26 as my answer. Okay? As always, again, just plug everything back into check. Doesn't take very long. So I'm going to get 3 and then 3 times 26 minus 4, and see if that equals 1/4 of, oops, I'm running out of space, so let me just move everything over a bit, times 32 times 26 plus 56. And I know these numbers are kind of big, so, oops, I forgot to close that parentheses. There we go. Again, if you need to do the work on the side, do the work on the side, right? And you'll be fine. So I'm going to get 3 times, so again, if I needed to do that on the side, 26 times 3, 6 times 3 is 18, carry the 1, so that's going to be 78. and then 1/4 of 32 times 26. So again, I don't know all this stuff in my head either, so it doesn't take very long to just do it on the side. 6 times 2 is 12, 18 plus 1 is 19, placeholder, 2 times 2 is 4, 2 times 3 is 6, and that'll be 832. Okay? Then keep going. I'm going to finish inside the parentheses because that's my regular PEMDAS. 78 minus 4 is 74. 832 plus 56 is 888. 3 times 74 is going to give me 222. And then 1/4 of 888, super simple, just divide everything by 4, is 222. So then I can be very confident x is actually equal to 26. Okay? So go ahead and try the try 1, 2, and 3. And again, you can check those with the video in a moment. If you need a pause to write anything down, remember, always feel free to pause anytime during the video so you can jot down all the notes. Okay? I'll go ahead and just shift my paper back. All right. So the last thing we're going to do in today's video is go over what's called an identity and talk about when we have no solution. That's the other big vocabulary word here. So if you look at the note here, all real numbers are solutions to an identity. So what do we mean by all real numbers? We mean every single possible number in the real number system. So positives, negatives, square roots, fractions, they're all possible solutions to that one equation. So how do we know if we have an identity? That's when an equation is true for all values, meaning we get a value that is equal to itself when we solve. Okay? And that means we have infinitely many solutions. That means every single number we can imagine that's real is a possible solution. On the other hand, if there's an equation that's not true, meaning you get like 5 equals 7, that's not true, that's when we have no solution. So we actually have 3 possible solutions to every type of equation, where we get one number, like we saw before, infinitely many, which is called an identity, and no solution, meaning we get something that's not true. So let's check out C and D and see if we come up with an answer that's no solution or infinitely many. So let's go ahead and just solve like we normally do. So I'm going to distribute to get 12D minus 1 equals 12D. And you might already say, wait a minute, 12D minus 1 can't equal 12D. And you're absolutely right about that. But and you can stop right here and say there's no solution. But if it's not super clear, keep going, right? Keep going until you're definitely sure it doesn't make sense. So I'm going to take away 12D from both sides, and I'm going to end up with 2 zero pairs. So we're going to end up with -1 equals 0, which I think is super, super clear. This doesn't make any sense because -1 can't equal 0. So that's what we mean by an equation that's not true, because -1 will never equal 0. They're 2 separate values, so that's when we have no solution. And in this case, it's really hard to check when there's no solution, so what I would suggest you do is just double check your work. Go back and double check and see if you did everything in the right sequence. You can also just plug in a value for D and play with that as well, but that's not always as clear. Okay. Taking a look at the last example, again, solve like we normally do, and when you come up with either an identity or a non-true statement or one answer, then you know you're done. So I'm going to get 21 minus 7W equals 21 minus 7W. And here you can already say, hey, they're the same thing. And that's when you can stop and say it's an identity. But again, if it's not super clear, keep going, right? So I'm going to add 7W to both sides because I normally want to put all the variables on one side. And then it becomes really clear 21 is always equal to 21. So that's always true. Which means we've got an identity, which tells us we have infinitely many solutions. And I do want you to write down infinitely many solutions. So it's great to recognize it's an identity, but then what does that mean when it's an identity? It has infinitely many solutions, and the solutions are actually what we're looking for. So that's a little tricky. I want you to be able to check both. Is the equation an identity? What does that mean in terms of the solutions? Okay? So we're just going to go ahead and finish this off and go ahead and try those U-try problems 4 and 5, and then we'll check those answers before you're done with the video. And we'll do the word problems together. Oh, I'm sorry, 4, 5, 6, and 7 here. And then we'll finish the notes in class with those word problems at the end. Okay? Remember, if you have any other questions, feel free to come back to class with them and let me know.